Now we would like to go to Arno from MARIN and talk about 7 Oceans Simulator. The floor is yours.
Thank you. Thank you for the very nice introduction. Start with how do I feel? I feel a little bit pressure because we have seen such good presentations already. So I do a presentation together with my colleague, Huisman. He's human factor specialist at MARIN. MARIN is a maritime research institute in the Netherlands. I have the job as manager of the simulation and visualization department at MARIN. I'm responsible for all the simulator facilities at MARIN, but also the simulators we sell to our clients. We will have a brand new simulator center. This is just virtual, it's not ready yet. We will start building it the 23rd of June and it will be completed in the first quarter of 2024. I will explain what the new simulator center is and what is the role within MARIN. And after that, Huisman will take it over and he will explain how this simulator center can be used by showing a virtual crisis playground. Seeing this picture, at the lower right, you see the mission of MARIN, better ships and blue oceans. And blue oceans, we do mean sustainable use of the ocean. But we as MARIN, we also want to help our clients to make shipping safer, smarter and cleaner. And if you look to this picture, it looks a little bit like the future, but actually it's not the future, it's today. We all know that now we are in the middle of the energy transition, so we are moving from oil and gas to very large offshore wind parks, but also floating solar panels are there. And it may be we have also floating islands to store all this energy and for the conversion of this energy. And maybe we are also going to live on these kind of islands. And as we heard more than once today, also the type of vessels are changing. You will see more and more zero-emission vessels like the wind propulsion vessels at the lower left. But also the number of crew is changing. We will have less crew on board of vessels, so we are going to automated vessels. And autonomous vessels will be more and more in this playground. So if we look to this playground, we will see more smarter and cleaner vessels. But safety becomes more and more an issue because the ocean will be more crowded. So how can we help as MARIN, as a research institute, how can we help our clients to make shipping more smarter, cleaner and safer? We at MARIN have great facilities and we are really well known about model testing. Since 1932 we have very large basins, or call it swimming pools, where we can simulate wave, wind and current. And on model scale we can test all kind of ship models and we can optimize hull forms. For example, the E-Tug from Keynote is also tested in our basins. I just heard during the coffee break. That's model testing. That's typically what we do during the design phase of a vessel. In the concept phase, we have also our own in-house built software, like computational fluid dynamics software, CFD. And the good thing is that our software is continuously validated with the model testing. But we do more. We have also monitoring. We have a department who is looking at the real vessels and looking to the data of the real vessels and checking if what we have predicted in front in the concept and design phase is correctly done. And then the simulators. When the man or woman is also in the loop, she is operating the vessels, then we are talking about simulators. And again, the simulation software is developed in-house. It's the same software as we're using for desktop studies. So the good thing is that our ship models in the simulator are also validated by model testing and by numerical calculations. And that is very important because we think the ship models must be right for research studies. Traditionally, the simulators are used between the design and operation phase. The design is already there, and then you can teach and learn people how to operate these vessels. Or you can train or research very complex maritime and offshore operations. But what we are doing already right now, but we are going to do it more and more, bringing in the simulators also to the concept phase. So you have your first idea, you have your first innovative ideas, and you can test them already on the simulator. For example, if you have a new yacht design and you have several options, Why not bring in the future owner on the simulator and let them feel on a motion-based platform which of the concept is the most comfortable yacht for him in future? Another idea is advisory systems. You can test already advisory systems on board of the bridge of the simulator, and then you can further optimize this tool. This is what we're going to do more and more, also in the concept phase. But we have already simulators for a long time. In 1972, we had the grey and white. I said we, but I was not there yet. But the life was grey and white, and we had our old simulators. And in 1992, it was upgraded to the simulators we have right now. And to be honest, the hardware is a little bit outdated, but the software is continuously developing, improving by the model testing and the numerical calculations we do. So the hardware is outdated, and that is the reason why we go to the new simulator center in 2024. We will bring full mission bridge simulators like STC already have, and MARIN also. But we also bring new technologies like VR, AR, and I just learned also assistant reality. I think that's very interesting to bring in our simulator center as well. We will experiment with all these kind of new technologies, and let's see if this can help our clients to make the shipping smarter, safer, and cleaner. What will be really new and unique in the world is this large bridge simulator on a hexapod. So it can move in 6 degrees of freedom within a globe with a diameter of 60 meters with 30 projectors on top of it. So bringing the motion also in the simulation is really cool and new, and I think it's even an improvement of what we already can do. Looking to the simulators, I just show 3 of them, what we already have. It's very important to know that we can connect these simulators also. So you can bring in several ships within the same scenario. The lower left is, for example, a smaller vessel that can be a tug, which is connected to the full mission bridge on the upper left. The lower right, we have already built a moving simulator, which is only for a 2-seat vessel. This is for the fast, small ships for the Navy. It was designed for the Royal Dutch Navy because all the instructors had problems with their knees and the backbone because they were really bouncing. So that's why we've developed this. And technically, this is quite a challenge. Why it is a challenge? For example, if you want to accelerate your vessel, you want to have the feeling of acceleration, but you cannot accelerate through the whole building. So what will happen is the motion base will be tilt a little bit, you feel pressure in the back, and you have the feeling of being accelerating through the building. And that's nice, but what will happen when I'm tilt, also my horizon has to be corrected because I'm looking upstairs. So that has to be corrected by the software as well. So it looks nice, but it's still a big challenge to get this motion cueing right. This is the system architecture, and you see XMF you can forget, but the most important part here, what I want to explain is the calculation kernel of our simulation software is again validated with the model testing and the numerical calculations. So we say that the behavior of the ship models in our simulator are really good, but not only of the single vessel, also the interaction between vessels is very important. For example, if you are the large vessel generating your own big bow wave or stern wave, the other small vessels alongside them has to feel those waves also. That calculation kernel is also calculating the waves, and also that is very important. The height of the waves and the frequency of the wave is calculated, but also visualized. So this is the visualization part. And why is that important? When I'm sitting on the simulator, I see a wave coming. I also want to feel that wave. If it is not, then I will get problems with simulator sickness instead of seasickness, for example. The upper left, that's just the interface for the instructor. He can create all kinds of scenarios. He can bring in an area, several ships, and so on. And on the right, the lower right, you see the hardware in the loop. That can be a console, that can be controls, that can be DP systems from Kongsberg, it can be everything, and that can be interfaced with the simulator. And I'm talking a lot about the great facilities we have, and during the day. We have seen all kinds of fancy techniques, but Hans Huisman is also here, so he's the human factor specialist. So I have to say this, the human is also very important. But I think he's right. We also analyzing the people operating the vessel. And how you can do that, for example, with eye tracking, you can see where he's really looking at. For example, if you have designed a new advisory system, is he really looking at that system? Is he overloaded with too much information? That you can test already on the simulator. You can also measure the brain activity or the lack of brain activity. Is he overloaded, yes or no? What type of studies you can do with simulators of MARIN? If you look here at STC, you have also great simulators. And it is to train people or students how to operate the vessel correctly. Perfect. That can also be done without simulators, but it's more important when you have very complex operations, like the installation of a topside offshore construction, and you have to place it on that floating bar. Then it becomes more complex, and the behavior of the waves and the ships and the multi-body, that is more interesting. And then you need to do more research, and then the behavior of the vessels must be right, but also the behavior of the waves has to be calculated correctly. We also use the simulators for port design. For example, we are in Rotterdam, the Maasvlakte 2 is also tested during the design on the simulator. Then you can test if even the biggest container vessels guided by tugboats can enter safely into Maasvlakte 2. And you can still change the design of Maasvlakte. I will give you 2 movies. It's always exciting if they will work. The first one I will show you is the installation of the offshore construction. You will see 2 large vessels carrying a large topside, is sailing over the bar, which is also floating and has to be lowered down, so by ballasting. And you will see that a lot of experts and hardware are in the loop. It's a short movie. So you see the 2 large vessels, the topside on it, you see the operators, and this is very important. They train already this very complex multi-body operation. There is the DP, dynamic positioning operator, in the loop. There's the ballast operator in the loop, ballasting those vessels. There's the superintendent, and there is also, of course, the captain of the ships. And you see more than 1 tugs connected to this operation, and the design of these configuration of tugs is changed during this training on the simulator. And you can see what are the operational limits for these kind of operations. This one is just nice to see. When you visit MARIN, I will put you on the hexapod. This is the fastball ship simulator. It can accelerate to 1.5 G. Above that it will be cut off, otherwise you still get problems with your back. But for training purposes, this is very interesting. And in the new simulator center, you will have the bridge of 4 by 5 meters in the globe also moving. And that is really new for us. So that is one of the large full mission bridge simulators, but we have also the one with the Mickey Mouse ears. We are not allowed to say it, but I do it. They're small, also globes, 6 diameters, so you can also look alongside your vessel. You see the small tug sailing your big vessel, for example. And again, the simulators can be connected. The empty space on the right, that's interesting for you. There we will bring in all kinds of VR, AR technologies. We will experiment, and some of them will be really successful and some not. And when it's successful and when there is a business case, we bring it to the market and we start researching new stuff. We will also have there a cable robot. Sounds cool. A cable robot is a lot of cables and you can move an object through the building. The same cable robot is also used, for example, I don't know if I can say it here, in the Amsterdam Arena. There you have the camera, he's moving through the stadium and can follow the players. We can move objects, and why it's interesting, Hans will explain it, but for example, when you're sailing next to a large vessel with a crane and the hook is coming and you want to grab that hook, you can test this. You stay on the motion base and it's a very dangerous operation. Why not testing it in a simulator facility? This is my last slide, and I want to welcome Hans. The floor is yours.
Thank you. I'll take over. Arno explained our new simulation center, and I will dive into a little bit more detail what we can achieve with this center. A multiplayer crisis situation, as an example. It's a building with a lot of simulators, and it's not just a bunch of individual simulators. What we foresee is to create a situation in line with what Berend explained this morning. If you have a vessel with a crew of 60 people, the journey starts. We want to create a situation in which we don't have only one crew from one organization, but we have multiple players from multiple organizations, different cultures from different organizations, and how do you cooperate, especially in a crisis situation. Why? It's not for a day-to-day training situation. They'll be too expensive, but to have a mission rehearsal and to discover the weak spots in cooperating between organizations and the weak spots within your organization and improve that. How to improve? That's the next step, of course. You can think about more training, new procedures, but also definitely increase or improve and introduce new technology. I'll zoom into the drifting of the Giulietta D. Especially Dutch people will remember that. And I'll zoom into a situation which we can recreate. On the left side, the real vessels. On the right side, the simulated version. And the idea is to create an environment where each operator of each organization will have a realistic environment, being able to perform a job as in real life, as close to reality as possible. So, what's the crisis we're looking at? End of January, a heavy storm on the North Sea. On the left side, lower left side, you see the Giulietta D. It was on the anchorage area. You can see on the map on the top in the pink region. It started drifting, and it started drifting towards a wind farm. It collided first to a vessel also in the anchorage area, and then it collided to two objects in the wind farm. Before it was connected to an emergency towing vessel close to The Hague, and then it was towed to the port of Rotterdam. So, who was involved? Of course, the crew of the Giulietta D. There was an emergency towing vessel from the Coast Guard. We had two tugs bringing it into the port of Rotterdam. The lifeguards were active. The Coast Guard Communication and Control Center in Den Helder. And the helicopter from the Coast Guard. So, number of organizations, a lot of platforms, a lot of players. How can we replicate that in a simulated environment? First of all, the Giulietta D. We've got on the right side our new moving base simulator. And as Arno explained human factors, I will explain some technical details on the simulator. It has a bridge area of 4 by 5 meters. A sphere-formed projection screen with 30 projectors creating a high-resolution imagery of the surrounding all around the crew. So everywhere you look from the bridge, you'll see an outside world, and you'll be moving around. And if you recall the videos from the incident, the vessel rolled quite a lot, so there was a lot of movement at that moment. The next one, the emergency towing vessel. We have the secondary bridge, the second bridge, as Arno called it, the Mickey Mouse. It's a large bridge from left to right. It's about 20 meters, a large projection screen, and on both sides you have the bridge wings with a a separate projection screen. So you have a good situation awareness all around. So that's the second vessel. Then the two tugboats. We've got smaller simulators, 4 of them. In this case, you'll need only 2 of them. Back to the fast small ship simulator. The lifeguard was active. Going up to the vessel in problems. On the left side, lower left, you see an actual picture during the crisis, and we can simulate this safeguard vessel in our moving base simulator. Then the next area in our simulation center is a multifunction area in which we can simulate vessel traffic management, shore control center for autonomous shipping, but in this case it can be used as the Coast Guard's communication coordination center and as a real crisis control center. Then going to the next step, having the crew on deck. It's a bit difficult to see. On the left you can see a picture of the bow, and the crew is wearing red suits on the red deck. Difficult to see, but people are walking on deck of the vessel in problems. On the right side, you see a picture or something we imagined to create. It's not existing yet. Having people in a mixed reality situation, wearing glasses, virtual reality glasses, in combination with reality. So for example, on a treadmill, you can walk around. On a small moving base hexapod to simulate the movement of the vessel and to create an immersive environment for someone standing on the deck. So basically this area of the simulation center is intended to create all kinds of replica situations on a vessel other than the bridge. The cable robot was already mentioned by Arno. Cable robot, nice development from the colleagues from Fraunhofer. Google it, it's really cool. The crew was picked up by a helicopter from the Coast Guard. A hook is lowered down, you have to grab it, and we can simulate that with our cable robot. Standing on a moving base platform, grabbing a hook, and be picked up from the vessel. We don't have a helicopter simulator, of course. We're a Maritime Institute, but we are having very close connections to our aerospace colleagues in Amsterdam from the National Aerospace Laboratory. They do have a helicopter simulator, so we are investigating how we can connect their helicopter simulator to our simulators. So, to summarize, we got one building with a lot of simulators, and all players from different organizations, we can connect, we can create a realistic environment for each of them and replicate a crisis situation. This crisis situation is an example for improving for future situations, but you can imagine that we can also simulate non-existing future operations and see whether new technology can improve the cooperation between the players within an organization or cross organizations. And that's how we hope that our new simulator center can, well, further shape our vision of safer, smarter, and cleaner shipping. Thank you.
Wow. That really looks like a really cool playground.
It will be.
Yes, absolutely. Some questions, some interactions, maybe some vulnerabilities from your side to try to open up to the connection. Maybe ask the questions to the crew. who you want to interact with? What's still keeping you busy at night? Maybe a short...
Now I can remember one of the questions, it was a student from University of Rotterdam. He was thinking, why not independent research? We are a knowledge institute, non-profit organization, so we are independent. And what we do sometimes, not sometimes, a lot, is joint industry projects. You can imagine, for example, the wind farms. All the ships will struggle with the wind farms. It's a danger. Maybe you can do research together in the simulator center at MARIN, but also the basins. So working together, looking for solutions, testing innovative ideas, come to MARIN, do it together, bring money together, and we have a nice playground to test. So I can ask to you, what kind of challenges maybe we can research, or should we research as MARIN? I can think of ideas, but maybe you have better ideas.
Yep. Please wait for the microphone. Then the microphone will come to you. And then we. Yeah, that's working together. Yes, team. Very good. Very good. Very good. Yeah. Yes.
Yes, thank you. I'm Bert Stoel. I'm a teacher of STC here, but I'm also a sailor for yachts at sea, at high sea. And I'm a question about the sailing ships, new way of energy, of course. Is that also possible to simulate all that kind of new developments?
Yeah, if I can answer that question, we are starting last month a new European project in which wind assist propulsion is the topic for large ships, vessels of about 300, 400 meters. It's a joint research project with a lot of industry for 3 years. And our role in that project is to simulate it on our moving base simulator. What's the impact of wind assist on the operation?
Because we have sails, but you can also use kites, all that kind of new developments also your interest over?
Definitely, yeah. That it will be a project in which wind assist will be the main topic, but a combination with hydrogen, electrification, etc. And maybe you can say something about Giselle.
Yes, traditionally MARIN is looking to the outside of the vessel, so we can optimize hull forms. That's why we have the basins. But you see the transition from to renewable energies and zero emission vessels. So we also want to know and understand our clients better what's happening inside the vessel. So we are also simulating right now the propulsion train within the vessel, and we are moving from diesel electric to batteries to LNG. And then you see the combination of what's happening outside and inside the vessels. Not to be competitive with Wärtsilä or other companies, but to understand better our clients.
Understand. Thank you for your answer question.
Thank you.
Someone else?
Any other questions? So,
Once I start singing.
I've got a question. So I think with all these great institutions and knowledges which you obviously have within house, it is a very powerful non-for-profit or partner in a consortium. And of course, there's always this money involved, specifically in innovation, because you guys make your money during the innovation and then finally providing something for better ships, blue oceans. And in that phase of building a consortium, it is always an interaction, what's in it for you, what's in it for me. Could you, with your experience, how to build such a consortium to actually apply for grants and work towards that, do you have any tips or tricks for people who would like to operate with you guys?
I think one mechanism MARIN is using quite a lot is the so-called joint industry projects. Individual companies don't have the budget to make a big step forward. So what we are doing in a number of cases to have multiple companies around us giving a little bit of budget. And if you combine it, we have a large budget, you can do research. And the result is for everyone within that group. and it will remain within that group for a couple of years, and after that, information will be open.
Okay.
At this moment, we are having a YIP running with about 70 to 80 partners, so it's really big, concerning reducing loss of containers at sea. It's an important topic, and if you start with such an initiative, then it becomes apparent that a lot of companies and institutes are interested, and they do have the budget, a bit of budget, to chip in. And if you add it up, then you have a nice research budget.
Great. Well, thank you very much.
That's a good mechanism.
Yep. Yeah.
With your
2 seconds. The mic.
Thank you. With your research projects and your simulations, I believe that you gain a lot of, let's say, learnings and results. And what we as STC are particularly interested in how do these innovations and these learnings change, let's say, the competencies of the people that need to be working on the ships? Is there a changing type of skill sets requirements? Are you touching upon that aspect too? Or is there a way in which we can discuss this as well? Because bringing in new innovations also bring in new skill sets or new requirements for people who work in these environments, and that is what we need to know as a learning institution.
Yeah, maybe that's my personal journey beyond started
Love that.
morning on. I'm from the aviation world, and only 3 years ago I stepped over from the aviation to the maritime world. And that was quite a culture shock. In aviation, everyone learns from what went wrong or almost wrong. In aviation, an accident is an expensive lesson, and a near miss is a free lesson. And everyone can benefit from such a lesson. And in the maritime world, if something went wrong, it's a huge cover-up. It's who done it, and who's to blame, and who is going to pay for it. And if that's solved, everyone shuts up and we haven't learned from it. So it's a bit annoying for me personally that we are doing research for companies who are paying a lot of money, we are doing a reconstruction in our simulator, and then say, okay, what have we learned from it? That's not interesting. Now we know who is going to pay the bill. Hang on, so this accident will happen again. Yes, this accident will happen again. So that's my personal drive to hope to make a step that we can zoom into what happened on board. What happened on board of the Julietta D? We have no clue. We jailed the captain and end of story. And how can we use that knowledge? And we have a lot of crews in our simulators, and we can use that knowledge. So it's a good question. I'm not sure how to tackle that, but it's my personal mission to make a step in that direction. I'm not over-optimistic that we're going to make enormous steps, but yes, we'll have to. Because if you introduce new technology on board, competences will change. What will be the impact on the operation? What will be the impact on safety, efficiency, etc.?
And bringing in new skills. I think the perfect example of this new assisted reality, acceptance is still a challenge, of course. So bringing young people, future crew, to a new simulator center, to an environment, and discuss with them, are you going to use this system? Or why not? What is the reason? Or how can we further improve it? So together, we will find out what are the new skills.
It happens to be that within STC we have the next generation in-house. So thank you so much.
Yeah, and if I may just add to that, I have done a lot of crew resource management, standing on these simulators a lot with teams. And the interesting part, and that's also what we just discussed, is actually that the intake sometimes is from a safety perspective or from an insurance perspective. And that you have to do the tick in the box and then you're able to fill the hook. And you come into enormous problems on board actually in practice because that guy was just sick at the moment, so nobody can click in yeah, we have to click it. So there's all these things where we have to do that. And then you come into education as a young person who comes there. I believe that if we can generate his intrinsic motivation to actually see how we can contribute and learn from the past without having to do that from a safety world or from a technical world or competency world, then we really change the attitude and behavior of students and actually future workers for their entire career. So moving away from that control and going into trust already starting at school will be is I guess where these personal journeys of you two maybe interact. So that's interesting to discuss over lunch, because now it's lunch